Hi, welcome to the last video in lesson 2-3. This is curve sketching. In this example, we just have one last curve to sketch. So I'm going to go ahead and minimize myself and let's look at example 6 here. We have y equals x plus 1 over the square root of x squared. So just going through these values here, again, our domain cannot be 0, and right, that would make our denominator 0, and due to this, right, we're going to have a vertical asymptote. Vertical asymptote at x equals 0. Now, since we didn't have any factors that canceled, there are no holes, and because of our vertical asymptote here at x equals 0, right, and visually that's gonna be right here. Due to this, we're not gonna have any y-intercepts. There will be none there as well. Okay, so an x-intercept, again, remember if you want to calculate your x-intercept, x comma 0, I'm gonna plug in 0 for y and I'll solve. So this gives us 0 is equal to x plus 1 over square root of x squared. Okay, when I multiply by both sides of the square root of x squared, this disappears, and we get x equals -1. Okay, so your x-intercept is at -1, 0. Okay, so last but not least, we'll talk about end behavior. So our end behavior graph, and I just want to move this over so we have enough room. So -1, 0. Okay, and end behavior. Well, I want to analyze what's the limit going to be at positive infinity. Okay, and essentially what we have here. Oh, my Estes is calling me. I'm going to pause this video and take this call. I'll be right back. All right, my Estes. I'll talk to you later. Thanks. Yeah, I just got off the phone with my Estes. He answered some questions. But back to this problem. Okay, so we have the limit as x is approaching infinity of x plus 1 over the square root of x squared. And remember, when we're talking about limits, we're talking about horizontal asymptotes. We only really need to pay attention to the leading terms. So I have x over, and then we have the square root of x squared. That's kind of like the absolute value of x. Okay, so if I plug in an infinity, positive infinity, right, I'll do some sign analysis. That's a plus over, and then a positive infinity in the denominator. That's a plus, so that's a plus. So this is approaching positive infinity. What am I talking about? I'm lying. This is approaching 1. The terms are the same, so we take the ratio, right? So it's going to be a positive 1. Okay. Now we'll do the limit as x approaches negative infinity and I'll take my reduced terms, so root x over absolute value of x. So in this case, I'm going to plug in a negative infinity. Okay, that's a negative, and then I plug in a negative infinity into the denominator, which is absolute value, right? It's going to be positive no matter what, and this is a negative. So again, the ratio is 1, okay, but it's going to have a horizontal asymptote at -1. So there's our information, okay, and we're looking for a starting point. So we'll go ahead, we'll get to that in a second. So here's what I want to do. I want to go ahead and graph this. We have a vertical asymptote at x equals 0. Okay, we have a x-intercept at -1, 0. Okay, and I know that my end behavior at +1 and at -1 we have horizontal asymptotes. So as x goes to infinity, I have a horizontal asymptote here. And as x goes to negative infinity, we have a horizontal asymptote. Okay. So I'll go ahead, we'll graph this. So I'm going to start out here. I'm going to go up, approaching positive infinity. Okay. This asymptote is even. That's also important to note, right? Because of the squared term here. Okay, so I know that it's going to come down from this direction. And I want maybe like a point over here. So what I'm going to do is I'm going to plug in 1. Okay, and when I plug in 1, what I get out is 1 plus 1 over 1 squared, which is 1. And I want the root of that, so 2 over 1. 2. Okay, so I have a point at 1, 2. So about here. Okay, and there is our graph. Okay, so again, in these videos, we identified these key features of a graph from the algebraic form, and we sketched the curves.